think it's on.
All right. Hey, good morning, everybody. Thanks for coming to our session this morning here in the Code Theater. Today, we're going to be talking about a VCF automated brownfield migration using PowerCLI. We're going to show you what Charles Schwab was able to accomplish with PowerShell and how it was able to, they could migrate an entire environment from one VCF environment to another. So it's going to be a pretty cool session today. My name is Ahnemann. I'm a senior technical account manager here at VMware. And then this is Matt Villilo. He's a senior data center engineer at Charles Schwab. Oops. All right, here's our obligatory disclaimer slide. Got to have it here for you today. So just keep in mind some of the stuff that we're showing you. It may be a little forward thinking, but we may talk about a few things here that are kind of interesting. So what are we going to do today? So we're going to show you how Charles Schwab used PowerCLI to do a brownfield migration. What's really cool about this is Charles Schwab uses NSX in their environment, and that's not something that you would typically see in a brownfield migration just because it's not in the product here today. But using PowerCLI, he was able to, and PowerShell, he was able to actually migrate everything that included NSX. So he can move VMs that had tags assigned to them. He can move DFW rules. These clusters are vSAN enabled. Pretty complex environment, and he's able to do it with very, very, very little downtime, if any, and move, we're talking hundreds of servers from one environment to another. Now, why is this even an issue? Why do they have to do this? And it really comes down to scale. So Charles Schwab, obviously a huge customer, very large environment. We're talking thousands and thousands of servers. And you know, every product has scale limitations, and they were kind of approaching scale limitations in the product. So we needed a way to take what they had and split it into multiple environments in order to, you know, not hit those kind of scale limitations. So again, who are we? So Matt, I'll let you introduce yourself here.
Hi, Matt. I'm senior data center engineer with Charles Schwab.
And I'm, like I said, Kenny Ahnemann, senior TAM here at VMware, primarily focused on the NSX space, but also VCF. So here's what we're going to do today. We're going to do a little background. Kind of gave you a little heads up on that. Matt will explain a little more here in a second. He's going to show you the workflow as far as what this code looked like and how it was able to accomplish these migrations. And then he's going to show you some examples. And be sure to stick around because the tips and tricks are pretty important. There's a few things you might want to just take a picture of. Just, you know, let the things that Matt had to figure out be something that'll save you time in the future. So in that, I'll turn it over here to Matt.
Thanks, Kenny, and hello, everyone. Thanks for coming to the session. Since we only have 25 minutes to go through this, I'm just going to jump right into it. There were more than a few reasons why we had to come up with a comprehensive automated migration process, but here are a few of them from a high level. We initially had multiple vCenter servers and NSX managers, multiple vCenter servers in an NSX manager instance, which needed to be broken up. Evolving best practices called for single NSX instance per vCenter. Our growth projections meant that if we kept multiple vCenters in a single NSX instance, we would exceed some limits in NSX itself. And then by splitting out multiple vCenters into their own NSX instance, we could simplify lifecycle management of both environments. And because eventually these environments will be added into VCF. We also had to script it because none of the tools available at the time could migrate NSX tags for the VMs, as well as the VMs themselves. With this workflow slide, I mainly wanted to show the multitude of steps that needed to be accounted for in the script. Also, this isn't all the steps, but it is all the major parts of the migration process. The biggest hurdle with this migration wasn't necessarily the coding, but figuring out in which order things needed to be accomplished. Developing and testing the script unveiled unforeseen complications that needed addressed in the script, and some of them were process issues, such as problems with the infrastructure or script failure. The first step the script takes is performing pre-checks of the environment. Before the script even runs, we've already deployed a new vCenter and NSX Manager instance combination. We've also duplicated all the settings and configurations that are needed for the new environment. The pre-checks in the scripts are mainly there to ensure the migration is going to be successful. A couple things to point out here. To simplify the migration process, we actually moved all the networking from any distributed switch, be it an NVDS or VDS, to the host, straight to the standard switch. This allowed for easy host removal from vCenter and migration to the new distributed switches when added to the destination vCenter. Also, if vSAN was enabled, you had to disable cluster member updates for each host in the cluster. For those that don't know, this blocks vCenter from updating the vSAN configuration on the host. We don't want vCenter to be messing with vSAN while the cluster is split between the two vCenters. And disabling HA temporarily saves a not so insignificant amount of time for the entire migration. All right, so one thing I'd like to point out before moving on, and to paraphrase the great Dr. McCoy, I'm an engineer, not a programmer. So please take these code examples with a grain of salt. I'm sure many of you out there could code circles around me, but ultimately the goal of the script was to get from point A to point G in the most logical way possible. Also of note is that all the code you see in here is only some of the major points of the script. Almost all the commands in the script itself have been wrapped in do-until loops with try-catches to make sure the command succeeds. We had a lot of non-technical people helping us run the script, so it needed to be extra error. We needed the extra error trapping that wasn't included in this presentation. Since the script makes a lot of API calls in NSX, I created some simple functions to wrap code around the invoke web request commandlet. What you see in this slide is an example of the get rest call. It takes just two parameters, the URL and the PS credential object. Next is if the version of PowerShell is not 7, then I wrap .NET code to accept all certificates in a try catch. Not doing so would have produced errors at any time. Next, our NSX managers use LDAP for authentication. So depending on how the user entered their credentials at the beginning of the script, we have to get it into the correct format to send to the NSX API. After that is the actual invoke web request line based on the PowerShell version that's running. Then we convert the JSON code that's returned from into a PowerShell object and return that to the script. I also created other functions for put, post, delete, etc. And each is slightly different based on what API call to make. I could have combined all this into one function, but I found it easier to make separate ones. All right, so this is an example of the process we took to move the host networking from NVDS directly to vSwitch 0 on the host. The first step in the process is to detach any transport node profile from the cluster. Then the script grabs the current NSX configuration of the host, removes any named uplinks, loops through each of the VM kernel adapters in the configuration, and changes the uninstall path to the newly created port groups on the host standard switch. It then converts that configuration back into a JSON payload and puts that back into NSX. Once that's done, the script then initiates an NSX uninstall process for the host. Now, on the opposite end of the spectrum, here's an example of how the script handles moving from the VDS to a standard switch. First couple of lines here deal with collecting information about the destination standard switch and the VM kernel adapters on the host. We use a standard number of VM kernel adapters on all of our hosts based on a platform type, basically whether it's using vSAN or Fiber Channel. So we build the destination port group array based on the number of VM kernel adapters on the host. After that, the script loops through the list of VM kernel adapters to the adapter to port group array. Next, the script will invoke ESXCLI to get the physical uplink names attached to the VDS and put those into an array. Finally, we can use the add virtual switch physical network adapter commandlet to move everything over to the VSS in one action. Once the host is moved into the new vCenter, and if the host is utilizing NSX, the install and network migration back to NSX is really simple. And just drop the host into the cluster with the transport node profile, and we're off to the races. If NSX isn't involved, it gets a little bit more complicated. The objective here is to move all the host uplinks and VM kernel adapters over to the VDS from the standard switch in one go. To do that, we utilize the vCenter APIs and a little code capture to get the structure correct. The first thing that happens is collecting information on the destination VDS, VDS uplink ports, and host VM kernel adapters. At this point, the host would have already been added to the VDS prior to the migration, or prior to this, with no uplinks and no network migrations. Next is to create an empty host network config object. Then using the code generated from code capture, populate the network config object with the relevant data. In the second screenshot, you can see a few loops here where we're parsing out each of the VM kernel adapters and physical uplinks to be added to the network spec. Once that's complete, update the host to the update network config action of the host network system view. Now we're getting into the meat and potatoes portion of the script, the VM migrations themselves. The first thing the script does is to calculate the number of VMs to move to the recently migrated host based on a simple algorithm. The total number of VMs in the cluster divided by the total number of hosts count minus 2 rounded up. The purpose of the host count minus 2 is to ensure that the last host to be migrated has no running VMs on it when it's put into maintenance mode. Any of the VCLS appliances will get powered off. It will then split up that number into groups of 8 if there are more than 8 VMs to move. This is because ESXi supports a maximum of 8 concurrent vMotions. Next, for each VM to be migrated, the script creates a PS custom object that will hold variables about what's going on with the migration of any VM. That object is then used if the script is interrupted at any point to know exactly where the process was stopped. Now, I'd like to give a big shout out to William Lamb at this point, because without this next bit of code, we couldn't have automated this process in any meaningful way. The functionality of the built-in move VM commandlet wasn't able to perform a shared storage cross vCenter vMotion between different SSO domains like his function could. The whole point of the migration was to disconnect a host from one vCenter and add it to another without touching the storage. And William's function was the only thing that allowed us to move the VMs between those hosts. I had to modify it a bit to suit our needs, such as adding support for NSX logical switches and adding VM folder location. But all in all, it still is code, and that's the URL to his original function if you need it. Once the pre-work for the vMotion is complete, the script loops through each VM to be vMotion and runs the modified xMoveVM function. With the task ID that gets returned, the script will watch the VM's progress. Once the vMotions are complete for the current group of 8, the script will then apply tags in both vCenter and NSX Manager, apply any attributes. It will also test for basic network connectivity. All right, so here are a few tips and tricks for those that might be attempting this in your own environments. We had some Oracle rack VMs that used multi-writer disks that could not be vMotioned the way the rest of the VMs could. We had to modify the script and ask those teams to actually take an outage during the cluster migrations, because the VMs had to be shut down, removed from inventory, and then added to the inventory of the destination host and powered back on. Also, DRS in the destination vCenter, if that was turned on, it would sometimes move the VMs around after the migrations. And this caused NSX to momentarily see 2 VMs with the same name in it, or with the same name, and it took anywhere from 10 to 45 seconds per VM before NSX removed the stale one and any NSX tags could be properly applied. Next is always develop these kinds of scripts to the least common denominator. Something will go wrong that a less seasoned engineer won't know how to handle. And then create a system to handle script failures. I used a checkpoint system with a JSON file that I'll show you in the next slide. And finally, always be sure the cluster is in tip-top shape before the move to minimize issues during the migrations.
If I were to emphasize any parts here, it'd be these two here. Develop the script to be used by non-technical people, because if you run at scale, there's a good chance that somebody else is going to be running the script for you because you probably focus on other things. And then figure out how to accommodate failures, because nothing ever works perfect, right? So things are going to fail. You're going to run into issues. You may have to pause it because you got to do some maintenance. So he's going to show you how he was able to do that, and that's a really big deal. And I think that's what sets the script that he did kind of apart from some of the other ones, right? Just to be able to resume where you're at. So I'll let Matt finish that, but just those are important.
So this is a look at what I called our checkpoint file. Basically, any major variable populated by the script was written to this file in case of script failure. If the script ever stopped and was restarted, it would check the working directory for this file, and if it found it, it would load all the variables back into the script and continue where it left off. This ability gave us the ability to stop the script, work on an issue, get the host or VM back into a state where the script left off, and then restart it and keep moving forward. It also gave us the ability to back out of whatever migrations we were working on. If something catastrophic happened, and there were a few of those, we could change a value in the input CSV file, and the script would then start a complete new backout process using this checkpoint system.
That's where I did it from the screen.
And then finally, here's a look at the function to upgrade the checkpoint file. If the script calls the function, the script calls the function in a do until loop to make sure that the file is always accurately updated. The function itself would import the file from disk, modify the correct variable, and then write it back to disk. One thing to note is that the JSON file depth was never greater than 3 levels. We never had to go any deeper than that. In our script, we called this function a total of 106 times. I absolutely wanted to be sure that if the script failed at any major point during the migration, there would be no issues restarting it. The migration script itself ended up being around 12,000 lines of code. And while I haven't actually measured it, maybe 1/3 to 1/2 of all that code is dedicated to error trapping and saving variable values to the checkpoint system. And that's it. Is there any questions? Yes.
Was there a reason why you didn't do export and import VDS files?
Actually, we did. So that was one of the.
You can use those over there.
Let me think back. What was this happened last year.
Did everybody hear that question?
Yeah,
you want to repeat the question?
So the question is, why didn't we export the VDS from one vCenter and import it to the new? There was a reason behind that, but honestly, I can't think of it right now. It ended up being one of the things we wanted to do was start from a clean slate in these newer environments. And the older vCenters had been around for years. The configurations on them were of the VDS wasn't optimal. So by just creating basically a new greenfield system and then migrating everything over to it that way, we could control it better. And moving forward, we wouldn't have as many problems as we previously had in the old vCenter. Yeah. Did you have a question? What's that? I've been working at Charles Schwab for 10 years. No, we actually accounted for that in the script. So the, what's that? Yeah. Okay, so the question was multiple disks, VMs with multiple disks and multiple NICs. Did we have any problems with that? And the answer to that is no, because the script, we had copied let's deal with the NICs first. The script would catalog every VM's configuration, port groups, disk layout, any policies applied to the disks, stuff like that. And that was part of the pre-checks. And that dumped all that configuration into a separate file, report back to it, or pull that stuff back in. So when the VMs actually moved, the script knew which port group it came from for each NIC and would then just reassign the NIC and the destination vCenter to that same port group, and we use the same names between them. For the disks, it's actually part of Williams code. It just doesn't touch it. If the destination vCenter has the data store that's the same name as the one it's coming from, it didn't matter. It just moved all the disks with the same exact configuration.
Oh no!
I think this gentleman has. What's that? User error. The question is, what was the biggest issue that we ran into during this migration? And it was user error. We did have hosts that would fail at times, and we would have to go and then restart the script. But honestly, it was just some of our non-technical people like closing out the remote desktop window that they were running the script from and stuff like that. It was just little problems.
Do you have I would say, sanitized version of your code that you can share?
Do I have a sanitized version of the code? And I actually don't. Sorry.
It's a good question.
Certificate issues.
The question is certificate issues. No, there was no. Is there any certificate that, like, is there?
Custom self-signed.
Oh no, these were. We had always been using the built-in CA in vCenter to do the cert, so there was no issues with the importing and exporting. During this, it was vCenter 7, NSX 3.1, and the ESX vCenter was on 7, yeah. So
So if you had the capability to handle all the error checking, what's the capable of handling the errors and being running an automated fashion like goes up at the pipeline and stuff like user in large capacity via GitLab?
sure. The question is, with all the error checking, let me paraphrase this. And with all the error checking, why wasn't the script able to just check the error and continue on automatic?
They had logged into a jump host from the script.
Yeah.
Was it not developed in a way that it could run the organic pipeline? You could trade handle all of it?
It wasn't developed that way. Like it was. Yes, yeah, I'm not I'm not an Ansible guy. I know of it. I work with that. I've just basically worked with a PowerShell script, and I just wanted. We ran into this limit in NSX, and we needed it fast. And the way that I knew how to do it was through PowerShell. So I just went a logical process from A to B. Okay, the question was basically how big was the project? It was roughly 2,000 hosts and around 20,000 VMs. Because of our maintenance windows and schedules, it took us roughly a year to do all of these migrations. Any other questions? All right, thank you all. Oh. That was a problem with NSX and getting we wanted to keep the VMs running, and if we had done a disconnect and reconnect, it would drop the network connection for the VMs at some point, and we wanted to keep that down to a minimum. So we just used the cross vCenter vMotion as an easy way to minimize downtime for the VMs. Any other questions? All right, thank you all. I appreciate it.
Good job, Matt.